Algebra 1, Simplifying Exponents. Part A, we're going to focus on positive exponents. Let's start with some vocabulary, definitions, and formulas. So in math, when we talk about the base of a term, that is a number or variable that's being raised to a power. So some examples that I have there for you are 8x squared or x cubed. So 8 to the second power, x to the third power. So we have a number and a variable. Those are our base. Now the little number up and to the right, that's an exponent, and that's a number that indicates how many times the base is multiplied by itself. So here, the 2 and the 3, those are what we call the exponents. And then we also use the word power. And so 8 with the exponent of 2, or 8 squared, 8 to the second power, means 8 times 8, or 64. X to the third power means x times x times x. I mean, who wants to write that over and over? So we do a little shortcut where we use the exponent numbers. Now we're going to talk about how to simplify an exponent term and how to evaluate. In math, simplifying and evaluating are two different things. So when you simplify, you just use the properties that you have and you rewrite, in this case, the exponential term using positive exponents only. When you evaluate, you usually will get a number value. So we're going to rewrite the exponential term, but as a number value. So when we simplify, we just use the properties and usually get it into an exponential form, and then when we evaluate, we get a number value. Let's start with the properties of exponents. These may be review for you, and they may not. They are really important, though, when we simplify exponent terms. So our first property is called the product property of exponents. So these first words are going to change for you. We have the product, the quotient property, and the power property. So the product property, it's a shortcut, and it says when you multiply exponential expressions that have the same bases, that's key, then what you can do with those exponents is you can add them to get your final answer. So let's look at the examples. On A, notice we have x to the 5th times x to the 7th times x. Now this is just an understood first power, but let's go ahead and write that in, if I'm allowed to. Let's see. There we go. So notice the bases are the same. Then in that case, we can simply add the exponents, x to the 5 plus 7 plus 1. So what we'll have total here is x to the 13th power, or x multiplied together 13 times. And that's all we can do, so we've simplified. We can't evaluate. We don't know what x is, the actual number, to raise it to the 13th power and get a number answer. So we just simplify it here. It works the same, though, if your bases are numbers. Now 9 to the third power times 9 to the second power, we keep that same base, we don't change it, and then we add the powers. So that is actually 9 to the 5th power. And then I can evaluate that. So if I put that on my calculator, 9 to the 5th power is 59,049. And then finally our last one, so we have 2x to the negative 2 power, and we can have negative powers. We'll talk about that more in Part B, times 3x to the 8th. So first of all, we can just multiply our numbers together. 2 times 3, which is 6. And then with our exponent terms, because it's only the x here and here that are being raised to the power. Even though the 2 and the 3 look like they are connected, they actually aren't. They're just sitting next to them, multiplying. So we can take the powers, negative 2 and 8, and we can add them. So 6x to the 6th power. And that's all we can do with that. So that's in simplified form. Now our next property is a quotient property. So now when we're dividing, if you remember quotient means divide, exponential expressions with same bases, we're going to subtract the exponents. Now the way that I do it is I take the larger exponent minus the smaller, and wherever the larger exponent term started, that's where your term ends up. So x to the 5th divided by x to the 3rd. X to the 5th, so 5 minus 3. Oops. Which is 2. And our bigger exponent term was in the numerator, so our term ends up in the numerator. When there's nothing else in the denominator, it's essentially 1, but we don't need to write that. Now when we have multiple variables, we just do the same thing, but only with like variables. So our x's are going to be 2, and this is the first power, so we'll subtract those. Our y's are 9, and we'll subtract that. And our bigger exponents were in the numerator, so that's why I placed them in the numerator. So it'll be x to the first power, but I'm not going to write the 1. I don't need to. Times y to the 6th power divided by 1, but again, it's not going to change the value, so I don't need to write the divided by 1. Now lastly, it's a lot like a, but it's with the number this time. So I'll subtract my exponents, and I'll get 8 to the 3rd. And again, I can go ahead and evaluate that. Take 8 times 8 times 8, which is 512. Okay, lastly, sometimes you're going to need to take a power and raise it to a power. And when you do that, you're going to multiply your exponents. So we have m to the 4th, and then we're raising that to the 8th power. So we're going to multiply our exponents. So that'll actually be m to the 32nd power. Now when we have multiple terms, we have to take them one at a time. So we multiply. So x to the first power, 1 times 5 is 5. Y to the second power, 2 times 5 is 10. Z to the third power, 3 times 5 is 15. 4 squared raised to the 6th power, the third power, but when we multiply, 2 times 3 will be 6. And then, since we do have a number base, we can go ahead and evaluate that. So 4 to the 6th power is 4,096. On D, we've got a quotient there, but it's different bases, so we can't subtract our exponents, but we can raise them each to the second power. So we're going to multiply. So 3 times 2 is 6. So our power of x is 6, and then 5 times 2 is 10. So we get x to the 6th power over y to the 10th power. Make sure when you write your exponents that you superscript them. That means up and to the right, so they don't look like just a number side to the side of the variable that's multiplying. Now on E, we're going to do the same thing. We're going to raise each of those to the 5th power. So 1 to the 5th power, and then m to the 7th to the 5th. 7 times 5 is 35. Now 1 raised to any power is simply 1. So that would be our final simplified answer. Now let's practice the properties and simplify. So we're going to leave an exponential form. We're going to simplify and leave an exponential form. So number 1, notice that we're multiplying same bases, so we can add those exponents. So we'll have 3 plus 9, or 5 to the 12th. Now, since we were told just to simplify, that means we're going to leave it in exponential form. We're not going to evaluate it. Okay, here we're going to take our variables that have the same base, and we'll add those exponents since we're multiplying same bases, but v is not the same base, so we cannot add those. So we'll end up with t to the 5th, v to the 2nd, and that's all we can do. Now here's a little just fill in the blanks. You got to do some mental math. So notice we're multiplying same bases. So 2 plus something is 7. Well, if you think back to your addition facts, 2 plus 5. So we'll just say question mark equals 5. Now on to the quotient property. X to the 8th divided by, just remember that's actually x to the first power. So take your bigger exponent minus your smaller, which is 7. Wherever that bigger exponent started, that's where the term ends up. So, and in our denominator, all we would have a 1 is a 1, so we don't need to write that. It's just x to the 7th. Here we have 5 to the, and we're going to subtract 5 to the 3rd power. We'll just leave that in exponential form. Now with this one we have a few things to do. So first with our numbers, 2 over 4, we're going to treat those like a fraction. So we can, and we'll just reduce that fraction to 1/2. I'm not going to write my 1, but I will write my 2. Now with my a's, I'm going to subtract here. I don't have any other b's. And then with my c's, I will subtract those, 4 minus 2. So up in my numerator, 3 minus 2 is 1, a to the first power, b, c to the second power, all divided by 2. All right, now practicing our power property. So we're raising powers to a power. So the first thing we need to raise each of these separately to the second power. So 2 to the second power. So I'm actually going to write that. So this will become 2 to the second power. Now I know you know that that is 4, but we'll do that in a moment. R to the first, S to the first. Okay, so we're going to have to raise each of these power to a power. So 1 times 2 is 2, so that's R to the second power. 1 times 2 is 2, that's S to the second power. 3 times 2 is 6. And now just to simplify a little bit, so we'll have 4 R squared, S squared, T to the 6th. Alright, and then with number 8, now we have a quotient. We're raising each of those to the second power. So we'll multiply. 3 times 2 is 6. Now 2 to the second power, we know that's 4, so we'll write that. And then b squared to the second power. And we don't have anything else to simplify. And then finally, this is n to the first power. 1 times 3 is 3, so third power. And then 5 to the third power. I'm going to go ahead and just do 5 to the third power, which is 125. Now we'll evaluate these exponential expressions, which means we'll take them down to a number value, but we'll first use exponent properties to help us do that. Alright, we have same bases. We're going to add the exponents. And then 3 to the 4th power. So you can grab your calculator, or you may know it. That's 81. Now this one actually tells us, it's saying negative 5 to the second power. So that, technically, that negative in front is a negative 1 times 5. But what that's saying is it is saying go ahead and square the negative 1. So negative 1 times negative 1 is positive 1, and then square the 5. So our answer would be 25, positive 25. You can also think of it as negative 5 times negative 5, which is 25. Okay, and then on 12, we're raising each of these to the third power. 2 to the third power is 8. Remember, this is first, so 1 times 3 is 3. 4 times 3 is 12. Alright, and then now go to your teacher talk and then complete the practice in Math Excel.